Okay, 12.3 is geometric sequences and series. So yesterday we talked about arithmetic, where you're adding to get to the next term or subtracting to get to the next term. Geometric is all about multiplying or dividing. So geometric, it's just a sequence with a common ratio, aka multiplying or dividing. One important skill with this is to be able to tell whether something it's arithmetic or geometric, or neither, because there's neither ones too. So looking at the first one here, if I do adding, I'm adding 6, I'm adding 8, okay, those aren't the same. If I do multiplying, it's like 2.5, nope, that doesn't work. So this would be a neither situation. There's no pattern there that we can see that it's arithmetic or geometric. If you look at the next one, if I go closer to the smaller numbers, 25, 5, 1, I know I'm dividing by 5 each time. So I know dividing is geometric. And then my common ratio, the thing with geometric is that my common ratio has to be in multiplying. So I'm multiplying by 1/5. All I do is I flip my number. Next one says 12, 36, 108. I'm multiplying by 3. Yeah, each time. So multiplying, that's geometric. My ratio is 3 because I'm getting bigger. Last one, looks like I'm subtracting. So I'm subtracting 3, yep, that works. So if I'm subtracting, that's called arithmetic. And my common difference would be -3. -3. Okay, let's go on to finding formulas. The geometric sequence formula is super easy. This is always going to be my first term. A1 means my first term. R is my ratio. And that's literally the only two things you need. My first term in this example is 625. And like we saw above, my common ratio is 1/5. So I plug that stuff in. AN equals first term 625, ratio 1/5 to the power of n minus 1. There's no simplifying. That's the answer. That's the formula. Give the first 3 terms of the given rule. So if I look at this thing, if I plug in 1 for my first term, it'd be 3 times 2 squared. Well, 2 squared is 4, times 3 is 12. My second term, if I plug in 2, I get 2 to the third, which is 8, times 3 is 24. You can see a pattern here going on. If you just look at the formula, like my ratio is 2. I'm multiplying by 2 each time. So if I use that knowledge, my third is I'm multiplying by 2, 48. Write a rule for the nth term, then find A7. So, looks like I'm multiplying by 5 each time. So that would be my ratio is 5. And the only other thing I need is my first term. So then my formula is my first term times my ratio to the power of n minus 1. If I want to find my 7th term, I plug in 7. And that you're going to need a calculator for. Let's go here. So we'd plug in 4, parentheses 5 to the power of 6, and I get 62500. That means my 7th term is 62,500. If I look at this one here, I'm alternating from positive to negative. So that means my ratio is negative. And then I'm getting smaller, so that's a dividing one, so it's going to be 1 divided by, what am I getting smaller by? 2. I'm cutting everything in half. My first term is 152, it says. So then, if I go to my formula, I got first term, ratio to the power of n minus 1. Same concept here. All that's happening is that it's in words and not in sequence. So it says one term, A4 is 12. That means my 4th term is 12. 1, 2, 3, 4. My 4th term is 12 because I need my first term, so I need to get there. my ratio is 2. So usually if I go forward, I multiply by 2. So if I'm going backwards, I divide by 2. Oh, and I wrote 14. Good job, Mara. That should be 12. So I divide by 2. I get 6, divide by 2. 3, divide by 2. 1.5. And I did that because I need my first term. So that when I go to write my formula, I do my first term times my ratio to the power of n minus 1. That's it. Okay, geometric series. So now we're adding up, add up geosequence. I'm adding up a geometric sequence. This formula is a little bit more tricky than the arithmetic formula. If you look here, I have A1, that's my first term. R is my ratio, used twice here. And N is my number of terms. So those are the things happening that I need. So it says find the sum of the geometric series. So I need 3 things. I need my number of terms that I'm adding up, my first term, and my ratio. To find these things is really easy. If I'm going from 1 to 16, I'm adding up 16 terms. My first term and my ratio is literally in my formula. My formula goes first term, ratio. So my first term is 4, my ratio 3. The trickiest part is plugging it into the calculator. So now let's do this. Sum equals my first term, 4, parenthesis, and then I got 1 minus my ratio, 1 minus my ratio to the power of how many I'm adding up. And this is where it gets tricky. So we got 4 parentheses. I know 1 minus 3 is negative 2. And then for the top here, I would plug this straight into my calculator. 1 minus 3 to the power of 16. That whole top. And I get negative 4, 3, 0, 6, 7, 2, 0. Now I can do that divided by negative 2. Oops, negative 2. Times it by 4. And get my answer. Yeah, that's a lot. Okay. In 1990, the total box office revenue at U.S. movie theaters was about $5.02 billion. From 1990 to 2003, the total box office revenue increased by 5.9% per year. So this is a geometric equation because I'm increasing. So write a rule. So for my rule, I need my first term, my ratio. That's all I need. So my first term, if it started in 1990, I'm looking at 5.02. My ratio, my R value here, I'm going to take this, move it 2 decimal places, so I get 0.059. But then if I did that, that would be decreasing, because that's less than 1. So since it's increasing, I got to add 1 to that. So it would be 1.059 to the power of n minus 1. So that would be my equation. What was the total box office revenue from that total period? That means sum. I'm adding all those together. So if I go to my formula for sum, I need my first term, 5.02, 1 minus my ratio, 1.059, 1 minus 1.059, to the power of how many years am I adding up? 14. So again, I'm going to do 5.02, and then on the bottom, I know that's negative 0.059, and I just got to do the top. 1 minus 1.059 to the power of 14 is negative 1.23, about. Divide that by negative 0.059, multiply by 5.02, and I get my total revenue is 104.76 billion. That's a lot of money. Okay. Next part is summation notation. This one is tricky and easy at the same time. We're going to skip these two just so you know. So looking at this thing, what's my pattern here? What's happening? Well, I'm adding 2 each time. So what kind of sequence is it? Is it arithmetic or is it geometric? Well, since I'm adding, that means it's arithmetic. Now, if I were to write it in summation notation like this, like you've seen it before, this bottom is always n equals 1. Always starts there. So So we got to figure out two things. We got to figure out how many terms and my formula. So if I go to my formula, an equals a1 plus n minus 1 times d. There's my formula for an arithmetic. Well, let's fill in everything we know. Well, I know my first term is 3 plus n minus 1 times my common difference, we found was 2. So I have 3 plus 2n minus 2 when I distribute that. So my formula is 2n plus 1. 2n plus 1. So that goes right next to it. Then the last thing I need is how many terms. Well, I don't know how many terms that is. I know that's the first, second, third, fourth, fifth. We got a lot in between there, and it goes here. So I can figure that out by setting 61 equal to 2n plus 1 and solving. If I subtract 1 over, I get 60 equals 2n. That means 61 is my 30th term. So I'm adding up from 1 to 30. Other one here, what's happening, I'm multiplying by 3, so that's a geometric. So if I go to my sum, I always start at 1. And at this one I know 1, 2, 3, 4, 5. I'm adding up 5 terms. Adding up the first 5 terms. Now I just got to put in my rule. My rule here is always my first term times my ratio to the power of n minus 1. Very nice. Very nice. Is that it? Is that all that's in 12.3? Yes, it is.